We're now on to a new topic, which is geometry or angles and shapes. What we're going to start with is a whole bunch of the words, so angles, notation. Really, let's just talk about angles. The first thing is, if you are asked to measure something, that means actually with a protractor. Just like if you were measuring a length, you would use a ruler. You don't just guess at it. To measure something means we actually need to measure the angle with a protractor in degrees. The second thing you could be asked to do with an angle is name it. And this is different to measuring it. You can't just have a rough idea for this either. You need to be specific. So if an angle has its vertex, the corner, and it has a point labeled on each arm, it could have multiple points on these arms, like there might be another point there called another letter. Well, then we'd have more options for how to name it, but I will get rid of that because we don't really want that. And what I want us to do is fill this in. So this angle, we name it starting on one arm, going to the vertex, turning the corner, and then coming to the other one. So it is named angle BAC because we can start at B, go through A to get to C, or, and that underline has disappeared again, we could call it going the other way. It doesn't matter if we call it CAB or BAC. Another notation that sometimes gets used would be BAC, and in some places in the world they put the little hat on top of the A. That is also an acceptable notation. But this symbol here, if I ask you what is the angle blah, don't just write BAC. The whole thing here, including the angle symbol or the word angle, needs to be given. One other thing here is if a diagram is super duper simple, we are allowed to call this angle A. Now, I don't really want to see you doing that, but I need you to be aware that some people and some textbooks in certain questions, some exam questions will actually talk about angle A. That always means the angle that occurs at A. We also have some slight other angles here. If we have a very big and complicated diagram, obviously we can't call anything angle A, or actually even angle G at this point. We've actually got two angles here. Actually, we've got 1, 2, 3, 4. There's a few of them. This red one is actually called not just angle DGF, because that's the path we've taken, or angle FGD. But we have to give a word at the front. We actually have to say this is reflex angle, and I know that this comes up in year 7, but it is something that a lot of us don't really, or isn't emphasized maybe by some of the teachers in year 7, and we just go around calling it that angle. We must call it with the word reflex at the front, because if you told someone you had angle DFG, well, angle DFG is always the smaller angle DFG. It's always the quickest turn if we're turning from DG to FG. The only way we can say go the long way round is to use the word reflex. As we move down a bit further, we've got a couple of other things here. Now you can be asked to classify or describe an angle. And these are the words we've all been dealing with since primary school, and we've gotten quite good at them. Any angle that is less than 90 degrees is called an acute angle. Any angle that is 90 degrees is called a right angle. Any angle that is between 90 and 180 is called obtuse. I often think of these as blunt angles and sharp angles because these ones are pointy enough, like a sword, they would actually cut something. An obtuse angle is quite a blunt object. Something that is 180 degrees is actually called a straight angle. You can consider it kind of a straight line as well. And any angle that is bigger than 180 and less than 360 is called a reflex angle. The one that is missing on here, of course, is if something is 360 degrees, we call it a revolution. The last thing we can be asked to do with angles is to calculate them. So can we work it out using the things that we already know? So let's have a go at this green example here. Well, in this situation, we know that if we went all the way around, that has to be 360 degrees. So we could even write this, since all the angles at a point, that's the way we describe it, must add up to, I'll get away with it, but just saying must make 360 degrees, well then that means we know that to work out M, we could work out what the rest of it is. And we could say, well, M must be whatever's left over if we want our 360, but we take away the other angles that we've already used up. So we take away 140 degrees. And again, like I have got in my warning over here, we either write M is 130, M degrees is 130 degrees, but we do not kind of mix and match between having units and not having units. So M equals to 360 minus 140 and minus the 90 that right angle, the square symbol represents. And if we work this out, we get 130 degrees. In this situation where two lines cross over, we know that A is equal to the 74. They have to be the same because the two angles, when they are opposite on two straight lines, are equal, and we say that's because vertically opposite angles are equal. Now, the expectation in terms of working out and giving reasons clearly increases as we go up through the grades up until year 10 and into year 11 and year 12, although they've taken a lot of the geometry out of the current year 11 and year 12 course. It is still something that our expectation will rise as we go through the grades, that you'll give clearer and better reasoning behind what you're doing. A couple of other words we might need to. Adjacent angles are the ones that are next, not next to each other. So they're the ones that share an arm. So we could have two angles. We have an angle on this side. We could have an angle on that side. And those two angles are said to be adjacent. Complementary angles are a pair. There are only two of them that add up to 90 degrees. And supplementary angles are a pair of angles that add up to 180 degrees. So that should be enough for you guys to have a go at the exercise.